In the previous chapter, we talked about standing waves. So you could have a wire and it vibrates. So you could have one end fixed, the other end fixed. So you get the fundamental mode, or you get the second harmonic, or sometimes called the first overtone, or you can have the third harmonic, or which is sometimes the second overtone, and so forth. And that's a wire. There are other ways of making notes, musical notes. One other possibility is, for example, an organ pipe, in which there's a little opening here and sound comes in here. Now, in this case, it's a little bit different because with the string that vibrates, the ends are fixed. So that means that the length is either half a wavelength or a wavelength, or 3/2 wavelength, or 2 wavelengths, etc. In this case, however, you have an antinode at the open end and a node down here. So in that case, the length is 1/4 of a wavelength, or you could have an antinode and then a node and then a node. So L is 3/4 of a wavelength, or it can be 5/4 of a wavelength, or so forth. And so all the odd fourths right here. And so in that case, it's going to be a little bit different. Okay. And so that's another sort of way of looking at this. And so there's all the other kind of things you can do. In class, there's an instrument that I use sometimes, to illustrate some other sort of things, in which it's just an open tube, and you blow air past it, and so one end is going to be an antinode, the other end's open, so it's an antinode. And so in that case, you have a node in the middle, and so you get this thing, and it's got, and so in that case, then it's again 1/2 of a wavelength, because it's going from antinode to antinode. That's half a wavelength, or 1 wavelength, or 3/2 wavelength, or so forth. So same as with the string. So let's consider an example here in which we have like an organ pipe, and let's say that on this particular day that the speed of sound in air is going to be 300 and let's say 341 meters per second. Now remember, the speed of sound varies with temperature. So on that particular day, 341 meters per second. And let's say the organ pipe has a length of 1.2 meters. And so I want to know what's the fundamental mode of what's the fundamental frequency, and the second and third harmonics. Okay, so that's the first and second overtone. Okay, so we look at it and we say, okay, so in this case, 1.2 meters, okay, and so we know that the length is 1/4 of a wavelength, okay, so that means the wavelength is going to be 4 times L, okay, so that would be 4.8 meters, okay. Frequency is going to be equal to C divided by lambda. So in this case, it'll be 341 meters per second divided by 4.8 meters. Okay, so 341 divided by 4.8 comes out to be 71.0 hertz. Now that's the fundamental mode. That's when it is an antinode at the top and a node at the bottom. So the next question is, okay, so the question is, it's 1.2 meters. Speed is still 341 meters per second, but I want to know the first overtone. First overtone is the second harmonic. So in this case, then that means the length is 3/4 of a wavelength. So that means the wavelength is 4/3 of the length. Okay, so that would be 1.6 meters. So the frequency, that's the second harmonic frequency, be 341 meters per second divided by 1.6 meters. So 341 divided by 1.6 comes out to be 213 hertz. Okay. And so you notice that that this is going to be slightly different than depending on how you build your organ. That it might actually end up not with all of the energy being in the fundamental, but you might have some of the overtones mixed in with it, and so that's why different musical instruments actually sound different. Is that they have a mixture of the fundamental plus the overtones plus the other harmonics, and so that gives them slightly different sounds. But this is an example here of another way of making using standing waves to figure it out. Now, of course, I could have done the next harmonic also, and so the next harmonic would have been like that. Okay, so from there to there is one wavelength, so that means L is going to be equal to 1 1/4 wavelengths, or 5/4 of a wavelength. And so lambda would be 5/4 L. And so again, once you got that, you just plug into the formula and you would get the next frequency. So again, frequency is still going to be C over lambda. And so that's how you find this for the next overtone.